In this video, we'll be continuing with electrical machines design, looking at the materials that are used in construction of electrical machines. So there are three main materials. We have conducting materials, magnetic materials, and insulating materials. All other aspects of machines are incorporated within each of these materials, and they are the ones which will be used in order to construct the machine. So any mechanical properties, electrical properties, strength and so on, magnetic properties are included within the materials as indicated here. So first, let's look at conducting materials. So conducting materials are those, simply put, that are able to pass an electric current. Right. These are the most common materials. They're used in windings and, of course, any other conductors within the machines. The main types of windings or other conducting materials that are used, we generally have copper or aluminium. So the advantages of these two types of materials are as below. Copper is generally the most commonly used, in terms of windings and conductors within electrical machines. This is because it has a very good conductivity and it is fairly malleable and can be manufactured. Yeah, it is soft and can be easily converted into wires for winding. And that process can be very highly automated and sped up such that you are able to create copper wires and windings that are very suitable for electrical machines. Aluminium, on the other hand, has the biggest advantage of being much cheaper or less expensive than copper. And it is still just as durable and allows electric current to flow. It is less conductive, but it is still suitable for certain applications. Right. Secondly, we have magnetic materials. So these are materials that will then allow the magnetic circuits, the magnetic field to be set up within them. So they are permeable to magnetic field. These are generally alloys and so on that allow magnetic fields to be set up within them. They are most commonly ferromagnetic materials. They are almost exclusively alloys of iron. So you can add nickel, copper, cobalt, all those kinds of things into materials to create alloys that have various characteristics, whether it is high permeability or low permeability, depending on the applications that they need to be used for. So in most cases, you will have either hard magnetic materials or soft magnetic materials. Right? Hard or soft depends on the ease with which a magnetic field is able to be set up within those kinds of materials. And this is referred to as the hysteresis that the materials exhibit. So hard magnetic materials have a large hysteresis. That is, it takes a lot of energy to set up a magnetic field within these kinds of materials. However, once those materials have been magnetized, it will take a lot of energy also to demagnetize them. So they retain magnetic fields for long periods, which makes them very useful in permanent magnet applications. Yeah. These are things like in such as DC and so on and so forth. So places where you have standing flux, such as those in DC applications. Yeah, and they are used in places such as solid cores and the relay cores. So the solid cores of DC machines and relay cores. These are applications where you want your magnetic field to be set up and it does not need to change. That's what we are calling the standing flux. It retains that flux within for a given period of time, right? And the materials that are used in this case are cast iron or forged steel. Yeah, they have high permeability and high mechanical strength. Right. Next, we have soft magnetic materials, and now these are generally used in the cores of electrical machines that have AC. Yeah, that is because they have low hysteresis. That is, it is easy to set up a magnetic field within these materials, but at the same time, they lose that magnetic field very quickly. So the hysteresis curve is very narrow. Also, they do not retain magnetism, as we've said, and they have a low energy loss after demagnetization or magnetization. So you don't incur losses to set up magnetic losses, to set up magnetic fields. These are commonly used in applications that have pulsating fields, which are of course AC applications, AC machines, and so on and so forth. Just move this. Similarly, these are used in laminated cores, whereby you have a magnetic field that is being set up and that you do not want to have a lot of eddy currents flowing, so you can be able to have a laminated core to prevent or to limit the amount of current that will be flowing. So it minimizes eddy currents. And these generally are electrical sheet steel or cold rolled grain oriented sheet steel. So those are the main properties of magnetic materials. And finally, the last type of material that we will be talking about are the insulators. So we mentioned insulators before. and these are generally used to separate the machine, separate current carrying conductors within the machine. Current carrying conductors from each other. So that means they need mechanical strength to a degree, because they provide mechanical support to the windings, but most importantly, they need dielectric strength. That is, they must be able to withstand a voltage gradient between the current carrying conductors. The key properties that they have are the high dielectric strength, which we've mentioned, and low dielectric loss, as well as thermal stability. So they have to be able to withstand higher temperatures, or rather the operating temperatures, without degrading within the machine. They must also be easy to machine or easy to manufacture and apply onto conductors. So generally things like varnish, plastics, resins, and so on and so forth, those are very useful in terms of common applications of machines. So finally, some of the main types of materials that we use as insulators are listed here. And these are the main categories that we'll have. Chief among them are, of course, the resins and plastics, which are used in wires and conductors because of their various colors and properties that are available. They are easy to apply and easy to make use of. Some of the other commonly used materials include asbestos because of its temperature resistance, as well as ceramics such as porcelain, which are used in bushings and switch gear as bases. Insulating liquids, which are cheap, but they can quench arcs. These are highly common in transformers and in cooling applications where you need a cooling medium that would be circulated through in order to act as a heat exchanger. Then you have various other cheap applications such as for wood and paper, and things like mica, which were used in the past. Another good alternative are the rubber materials, which have good thermal conductivity and they are stable at high temperatures. So these are very reliable for wires in low voltage applications. So those are the main types of insulating materials that we make use of.